Bismillahirrahmanirrahim. Today we will start our 10th lecture of course Calculus 2. In today's lecture we will see that how can we find out the directional derivative. Basically the definition of directional derivative is the rate of change of scalar point function in the direction of unit vector is called the directional derivative. The formula of it is d v and u x y is equal to the vector v, its determinant, and it will be multiplied with gradient of u. So now in our example we have to find the directional derivative at point 1, 1, 3 in the direction of origin. This is origin where u is equal to x, y, z. This is our scalar point function. Now we will find out the vector, its determinant and the gradient of u, and then we will put these values in this formula. So our step 1 is we have to find out the vector v. So we have the points, we have the origin. So to find the vector, v is equal to the point and origin. We will write it as this. The vector v, it will be origin minus point. First we will write the values of the origin 0, 0, 0, and it will be minus from 1, 1 and 3. Origin means the value of the x, y and z is 0, and the points given in the question, our x is 1, y is 1, but the z is 3. And we have to minus these values. So our vector v will be minus 1 I hat, minus 1 j hat, and minus 3 k hat. This is our vector. Now we will find its determinant, that is our step 2. And we will follow the same method as we followed in the previous lecture. So the determinant v is equal to under root the value of I hat direction, its square, plus the value of j hat direction square, and then the value of z hat directions square. So it will be under root 11. Now on the step 3, we have to find out the gradient of u. Now for the del u, our formula is partial by partial of x with the value of u, that is x, y, z, plus partial by partial of y and x, y, z, plus partial by partial of z, x, y, z. This is in the I hat direction, in the j hat direction, in the k hat direction. Del u is equal to y, z in the I hat direction plus x, z in the j hat direction plus, and partial of x, y, z by partial of z means x, y in the k hat direction. Now we have to put these values, these given values 1, 1, 3 at the place of x, y and z. So del u will be 3 I hat plus 3 j hat plus 1 k hat. You will put the value of the y, value of the z, value of the x, value of the z, and the value of x and y. Here this is the value of x, y, z. X is 1, y is 1 and z is 3. Now we have to put these values, this v, this one v and this del u in our formula. So the directional derivative will be, which is minus I hat minus j hat minus 3k hat. divided by the value of the determinant, that is under root 11, and we have to multiply the value of del u with it, that is 3i hat plus 3j hat plus 1k hat. And so our answer will be minus 3, minus 3, minus 3. We will multiply it with these values. Minus 1 and 3, minus 1 with 3 and minus 3 with 1. Divided by under root 11. It will be minus 9 by under root 11. So this is our directional derivative. It is like minus I hat minus j hat minus 3k hat into the value of the u, 3i hat plus 3j hat and plus 1k hat divided by under root 11. This. And solving it, we will get our final answer. And this is equal to the directional derivative.